Hello, you are welcome to this class. My name is Dr. Kingsley. In my class today, I shall be discussing Law Chatelier principle. Law Chatelier principle is a principle on chemical equilibrium. A chemical equilibrium is said to have taken place when the rate of forward reaction is equal to the rate of backward reaction, or when the equilibrium constant of a reaction is 1, or we can say when the free energy of a reaction is 0. Now, in this discussion today, Law Chatelier is saying that that there are some certain conditions that can shift equilibrium position. Remember, anytime equilibrium is established, now the chemical system want to maintain that equilibrium. However, there are some certain disturbances like changes in temperature, changes in pressure, changes in volume, or changes in concentration that can unbalance this equilibrium. And then Law Chatelier is saying that anytime a chemical system in equilibrium is disturbed by changes in temperature, pressure, volume, or concentration, that the equilibrium position will shift in order to annul or cancel those disturbances. Now, having gotten this, we can now agree that there are 4 important conditions that can shift equilibrium position. Number 1 is temperature. Number 2 is pressure. Number 3 is volume. While number 4 is concentration. These conditions can affect equilibrium position. Now let us look at how temperature can affect equilibrium position. Now, effect of temperature on equilibrium position will depend on whether the reaction is endothermic or exothermic. Remember, endothermic reactions are those reactions in which heat is absorbed. Their change in enthalpy is positive. On the other hand, exothermic reactions are those reactions in which heat is liberated, and therefore their change in enthalpy is negative. Now, how does temperature affect equilibrium position when the reaction is endothermic? Now, if we take a reaction A plus B, gas, to give me C, and we are told that change in enthalpy is positive. Anytime you are giving a reaction and you are giving the heat content, from the heat content which is change in enthalpy, you can actually know whether the reaction is endothermic or exothermic. Now, in this reaction, we are seeing positive for enthalpy. Therefore, the reaction is endothermic. What will be the effect of increase in temperature for this reaction? When we increase the temperature of this reaction, or we say that for endothermic reaction, increase in temperature shifts equilibrium to the right, thereby favoring the formation of products. That means that increase in temperature for this reaction, which is endothermic, we shift the equilibrium to favor more formation of C. However, if we decrease temperature for endothermic reaction, the reactant will be favored. Increase in temperature favors forward reaction, while decrease in temperature favors backward reaction for endothermic reaction. If we now have A plus C to give me D, and we are told that change in enthalpy of the reaction is negative, what happens in this case? Now, what happens here is opposite of what happens in endothermic reaction. For exothermic reaction, increase in temperature favors backward reaction. It is decrease in temperature that favors the forward reaction. So for this reaction, if I decrease the temperature, the equilibrium position will shift to the right, favoring the formation of more D. But if we increase the temperature, the equilibrium position will shift to the left, favoring the formation of more A and C, because the reaction is exothermic. Now, having seen how temperature affects equilibrium position, let us go to pressure. How does pressure affect equilibrium position? Now, for pressure to affect equilibrium position, there are two conditions that should be met. Number one is that what? The number of moles of reactant must not be equal to the number of moles of product. Anytime the number of moles of reactant is equal to the number of moles of product, pressure will have no effect on that reaction. That is to say, for pressure to have effect, either number of moles of reactant is greater than number of moles of product, or number of moles of product will be greater than what? Number of moles of what? Reactant, in whichever way. Now, number second position is that what? There must be gaseous species in either the reactant or the product. So there must be gaseous species. That means that what? Pressure based on gases, not solid and liquids, on gases. Now, having understood this, then we can now what? Take a general position on pressure. Now, what is the general position on pressure? Increase in pressure favors lower number of moles. Increase in pressure favors lower number of moles. Now, when we have 2A plus what? B to give me 2D, for example, and this is gas, and this is what? Gas. You may be asked, what is the effect of pressure on this what? Chemical system in equilibrium? Now, you check your two conditions. The first condition is what? The number of moles of the reactant and product must not be equal. What is the number of moles of this reactant? Here we have 2. We have what here? 1. So we are talking about stoichiometric number of moles. So we have 2 here plus what? Plus 1 here. That will give us what? 3. Then the number of moles of the product is what? Is 2. Which one is greater? You can see that the reactant is what? Greater. However, increase in pressure favors lower number of moles. That is to say that what? If we increase the pressure of this what? Reaction, the equilibrium position will shift to favor more formation of the product, which is D. However, if we decrease the pressure, higher number of moles will be favored. Increasing the pressure of this reaction will favor smaller number of moles, which is product. Then decreasing the pressure will favor the reactant, which is higher number of moles. So now, having seen this, we can be given another equation. Let's say you are given 2D to give you A plus what? D. And this is a gas, and this is a gas, and this is a gas. You might be asked, what is the effect of increase in pressure? Now, check whether what? The number of moles are equal. The number of moles of the reactant is 2. The number of moles of the product, stoichiometric number of moles, is 1 plus 1, which is also what? 2. Since what? The number of moles of reactant and product are equal, pressure will have no effect on this chemical system that is in equilibrium. Then I'll give you the last example on pressure. Let's say we have 2A gas plus what? 3D, and okay, 2A solid, okay, plus 3B, which is liquid, to give us what? C, which is what? Solid. You might be asked, what is the what? The effect of pressure? Sorry, what is the effect of what? Pressure, yeah, on this what? On this chemical system in equilibrium. What is the effect? You check your two conditions. The number of moles here is what? 5. While the number of moles here is what? 1. So that condition is what? Is met. Then go to the next condition. The next condition says that what? That there must be what? Gaseous species in either the product or what? Or the reactant. Is there gas here? No, no gas here. Is there gas here? No gas here. You can now see that what? Although the number of moles differs, but there is no gas in the what? In the chemical system. Therefore, pressure will also have no effect on that system in equilibrium. Now, having gotten how pressure affects equilibrium position, let us now go to volume. How does volume affect equilibrium position? Now, we know that from Boyle's law that volume is inversely proportional to what? Pressure. Or you can say that pressure is what? Inversely proportional to volume. What does it mean? The condition that affects pressure affect what? Volume, because they affect gases. But the issue is that what? Since they are inverse proportion, it means that if increase in pressure favors lower number of moles, it will then mean that what? Increase in volume will favor higher number of moles. So we have A gas plus 2B gas to give what? To give C gas. What is the effect of what? Pressure. Now, the number of moles here is 3. The number of moles here is what? 1. They are gases. So that condition is met. And the number of moles are not what? The same. That condition is also met. Therefore, what is the effect of what? Increase in volume. Increase in volume will favor higher number of moles. So if I increase the volume of this what? Of this chemical system in equilibrium, okay, the equilibrium position will shift to the what? To the left, favoring the formation of reactants, which are what? A and what? And B. Assuming it is pressure, increase in pressure will favor the smaller number of mole. But now increase in volume will favor what? The larger number of moles. So in a summary, increase in volume favors higher number of moles, while decrease in volume will favor smaller number of moles. Now we have gotten to learn about, okay, temperature, pressure, and volume. Now the last is what? Concentration. What is the effect, okay, of concentration on equilibrium position? Equilibrium position will always shift to favor smaller concentration. Now if we have A plus B to give me C plus what? D. Okay, it does not matter whether they are what? Whether they are solid, liquid, or gas. Okay, the only one that gaseous must be emphasized is only when we are talking about pressure and volume. But when we talk about temperature and concentration, we don't mind whether they are, okay, we don't mind the states of matter that they are. Now, what will be the effect of what? Of concentration on equilibrium position. Now let us see, for example, assuming we remove A, what do you think will happen? In this reaction that is in equilibrium, we keep on removing one of the reactants, which is A. You can see that what? The concentration of the reactant will decrease. And the equilibrium position will always move to favor lower concentration. That is to say, if we remove A, equilibrium position will shift to the what? Left, in order to replace the A that you are what? You are removing. Now, however, if we remove from the product, for example, if we are removing D, it is now the concentration of the product that will reduce. So equilibrium position will shift in order to replace the D that is being removed. Now, what of if we are adding? If we are adding, let's say we are adding what? We are adding C. The reaction in equilibrium, you are adding what? One of the what? Product. As you are adding C, you are increasing the concentration of what? Of the product. Therefore, the concentration of the reactant becomes smaller. So equilibrium position will what? We shift to the left in order to increase what? The concentration of what? A and B, so that their concentration can balance again. Thank you very much for your time. Please always do share, okay, like, subscribe to my videos so that I can get to other people. It will help those people who are preparing for NECO, WAEC, JAM, NAPTEP, okay, first year students, and those who are preparing for any A-level exam. Thank you very much.